Best practices in modular technology and cooling system at scale. This discussion is a review of the white paper that was just released on Monday. Hopefully you all saw that news. So we have this been working on it for a while. The modular deployment technology cooling solution, not going to introduce Wade because it's the same Wade that was just here. Would like to introduce my project co-lead or workstream co-lead, Hussam.
Hello guys, my name is Hussameddine Kabbani. I'm a data center thermal system engineer at Meta, and I'm glad to work with Don on this paper.
Thank you so much. So I am the mission critical division leader for Victaulic, but my involvement with OCP dates back to 2020 when I helped launch the Advanced Cooling Facilities project or sub-project, and then subsequently helped launch the Cooling Environments project in 2022. And then in 2024, I stepped down from cooling environments just to launch this work stream because I had some passion around the concept of our world was changing. And if you think about in actually 2023, all of a sudden this tsunami started happening. The tsunami was this wave of AI applications that Wade has started to talk about a little bit. Hussam joined me as the workstream co-lead. The workstream has gained global review and contributions and was published, as I said before, on Monday. And for those that want a copy of this, the QR code actually would download it to your phone or something else. Let me know if that works. So it's now published. It's part of the OCP website. Today's discussion is kind of like a book review, book club. We're just going to talk about what made you laugh, what made you cry, maybe some the emotional aspects of this paper. We're not going to have a chance to go into the deep depth discussions, but we're going to look at some of the highlights. So on the highlights, first off here, we have it broken down into two ways. And I started out with a basic topic flow, but then we found there were some topics that had so much depth to them, we had to put them in as appendices. We could have possibly published them as separate white papers, but it's just easier to put it all into one work group. So on the first part here, the concept of the key benefits for modular. Modularity is not a new concept that we've been talking about modular deployment since I've been in data centers, which is the better part of 24 years, and I'm sure Wade was talking about it long before that. But the concept is still needs to be looked at, and we're going to talk a little more specifically on how this cloud scale deployment, what Wade mentioned about, say, 8 versions of the same thing over and over again, really lends itself to a modular. Requirements for modularity was a key aspect in terms of it's been around, the concept's been around, why doesn't it work? And to a large extent, one of the key aspects is the pipes don't fit, or historically they haven't. So we looked at the concept of how to make pipes work together like Legos. Then Hassam's gonna actually talk about the
water-based fluid. So as you know, guys, we are trying to cool racks, and there is multiple options for liquids and fluids. So we consider basically like chemical properties, thermal properties, and fluidic properties. There is many options. There is like PG25, and there is treated water. There is a pros and cons for each. There is recommendations, there is preferences. But again, it's pros and cons based on those 3 different categories: chemical properties, thermal properties, and fluidic properties.
Then there was also a pipe selection. We looked at different types of pipe, which is you bring up the temperature ranges that were brought up here and some of the cleanliness requirements, narrowed that down to a limited number of options, but we didn't make a prescription. We just made recommendations, and a large application of stainless steel is very popular. But there are boutique applications that use other materials as well.
Oh, okay. Loop sizing to electrical bus capacity. So as you from fluidic perspective, right, we are designing this, imagine this big loop, liquid loop. And there is multiple components within this loop. And you have to design it based on a certain pressure drop on the CDU. Since we are talking about pressure, and since we are talking about like limits for velocity, you have to make sure that you are choosing your piping sizes to meet all different requirements from velocity perspective, cooling perspective, and pressure drop. And I want to put 5 lines under pressure drop.
Well, and actually, we talk about bus bar for LTR, bus bar for liquid to the rack. Can we make the bus distribution method? Can we echo that maybe with a liquid distribution method? Let you go in the branch line there.
Oh, okay. So again, guys, since we are talking about modularity, imagine that we have this huge piping system that's feeding multiple racks. So you have a CDU, there is a pump on the CDU, you have a huge piping system, and you have racks, multiple racks connected to this piping system. So you need this connection between the piping system and the racks. Some people call it branch lines, some people call it valve trains. But think about this, it's not only a connection. This branch is going to play multiple roles. First, it's going to be a connection. Second thing is going to control the flow to each rack. And third thing is going to protect the rack. If there is any leakage within the rack, there is valves on those like branch lines that's going to open and close. One of the topics, like Don was talking about crying, is the size of the size of this branch line, which are going to talk about it later. But yeah.
Yeah. So the topics we went to more deep, this concept of reliability and risk considerations. Historically, we put pipe outside the data center hall, and we come up with ways of making it safe. But with these Nvidia racks, they cost, what, at least $5,000 each, is it? Or
Somewhere north of that, but yeah.
maybe the better part of $5 million each, or maybe a little higher than that. We keep hearing different numbers. They have a sale right now. Buy one for the price of two, you'll get a second one free. But anyhow, that having been said, the exposure you have by running pipe right next to the IT rack causes us to look a lot at concepts that weren't looked at historically with pipe. We looked at failure mode effect and analysis. We looked at MTBF, mean time between failure. Is there a way to actually drive our reliability better? And that has a whole chapter on it. Let you talk about flow.
Oh, okay. Flow control and balancing. Again, same concept. We have a piping system, we have a CDU, and you have multiple racks connected to this piping system. So you have to make sure that you are delivering enough amount of flow to each rack without impacting the pressure drop throughout the whole system. So back to the branch line, there are certain components or certain valves that need to be on this branch line to control the flow to each rack without impacting the adjacent racks. So think about it as a big electrical, like analogy, electrical system where you have multiple resistances in series. You have to make sure that each resistance is getting enough current. Same thing for us. Each rack should have exactly the same flow.
Calculations and selector tools. A lot of this seems like a complex topic, but in some cases, you're just dealing with some basic calculations done over and over again. You're looking at PG25 versus water. What you're looking there is two different types of specific heat. You may be looking at one pipe versus another, have different internals. You can break this down into manually doing calculations, but what we did do is we actually created a selector guides where we actually were able to map out a broad spectrum of performance windows for a given number of variables and then a change and adapt, make it very rapid to actually evaluate these Legos, if we will. And you're going to hear that term Lego over and over again. All these complexity topics, when I first came around with Legos, I've been around for a while, I think there were 8 Legos when I first started playing with Legos. Now there's probably 8,000 or more. And so what we're looking at here is trying to come up with the first set of Legos to address some of these problems we're talking about in depth. I'll let you talk about this one there. 25 micron.
So filtration, again, the same piping system that we've been talking about, it's connected to cold plates. So we're worried when we have like a liquid cooling components in the rack that has cold plates. So the cold plate is basically a heat sink with micro channels between them. Problem happens when these channels become smaller in size, right? So you need to have some kind of filtration to make sure that those microchannels are not blocked. So we're recommending a 25 micrometer filtration that's going to be installed either on the rack or on the CDU. Oh, go ahead. Module sizing and valving. Okay, branch line. We are talking about racks, right? So there is a huge, so the power range per rack, it ranges from 50 to kilowatt. I'm hearing like high numbers. So again, since we are dealing with pressure drops, if you have high power rack, you need a huge amount of flow to cool this rack. So this means the pressure drop through the rack is going to be critical component. So when you do the sizing, of the branch line, like pipe size, hose length, hose size, hose diameter, valve sizes. You have to take pressure drop into consideration to make sure that you are not over-delivering or under-delivering delivering flow. Oh, also structure.
Go ahead.
Structural considerations, it's basically like the weight of the rack, how we are going to move it around in the data hall, and whether it needs supports or not, and even if the valve train needs a support or not, especially if it go in bigger in size.
And the commissioning considerations, the last thing on there, it really ties in a lot to this cleanliness requirement as well as sustainability and a lot of things. If we do off-site manufacturing, do you pre-commission assemblies, then take them on and recommission them on the job site? All these topics here had a fairly lengthy discussion and are going to continue to have discussions as we go forward in the coming year. But let's kind of talk about modular and just kind of why we're going here. It's not a new concept, but Wade, did we cover everything before? Or do we think you got is the book complete, or do you think we got a lot more to write about?
I think we got a good start. I think we got a really good start. I think we need more folks to contribute, not just the Apollo, SGI, Cray, Nvidia. Oh wait, we're all Nvidia now. No, just some people. Yeah, you know, we've been, many in the industry have been deploying at scale with liquid cooling for a long time, but now we look at, there are some people who believe that an in-rack CDU is a better answer, you know, and so, you know, as we start this, we tried not to, in the paper, you know, have the story that this is only about a CDU at the facility level. I think there are other committees here presenting that are talking about, you know, raising the water temperature, which again, you know, from, you know, Roger Schmidt temperature water to, you know, to Jensen temperature water. I just called it now. Roger Schmidt water, Jensen water. And then velocity. Again, you know, velocity, you know, in our grandpa's data center, oh no, we can't push it that high. You know, these are things that we need to have an industry discussion about it, because we will not succeed in saving the planet by using waste heat if we don't control so that we can take every volt amp in that went as a watt. And again, there are multiple committees on it, and so we try to leave that to those committees and leave breadcrumbs and pointers, but also, you know, we're not trying to be the one, you know, group that rules it all, but we are.
Well, and to you, what you're bringing up here is there's a lot of complexity, a lot of things, but if we break any of these problems down into, like I said, the Lego kit, we weren't prescribing a solution. We're not prescribing exactly what you need to do, what size pipe, but we're saying, or what length, or how, what modules. But if we have a set of Legos so each organization can solve for their own problems, and then we can mass produce those. And let's talk briefly about, kind of share back and forth. As you look at this Lego concept, we'll start with delta T and KW per rack, the variability of those. How does that play into, say, a delta, I don't know, Hussam or either of you want to talk about how that plays into modular discussions?
Well, I'll start because you saw in my slides that I talked about how today there is a 130 kilowatt rack with 100 kilowatts of liquid, and there's a support rack at a 1-to-1 ratio. But as we're building a data center of the future and we're hanging the pipe, it's like someday those other racks are going to need water. You know, so do we put a you know, a 1-inch drop for some and a 2-inch drop for the others? Do we do them all as 2-inch? Do we say, all right, you know, per 1 megawatt, it's 6-inch? Is that right? Whatever the, you know, if we come with an industry as a number that says, you know, and I think that's our biggest thing, is that we want to allow all the players of systems. Nvidia is a systems player, you know, Intel, AMD, Cerebras, Next Silicon, whatever, is that if somebody wants a different water, we need to make sure that we've got a fair playing field for the 1 megawatt shim. You know, if that's what it is, it's got to match the power feeds at the water temperature that they can allow. Some people can allow 41, others want to allow 25, that's fine. But I think that's our job, working with ASHRAE, you know, Department of Energy, the EEHPC work group. I think that's where we all come together, that says we've got to make it so that we don't stifle innovation in the IT kit because every plumbing is custom.
Yeah. So as we go around this loop here, the next thing is we already talked briefly about cleanliness, and one of the key challenges we have is this 25 micron. That is the size of a white blood cell. So dirt that's bigger than a white blood cell can't exist in many of these solutions. Not all of them. Some of them need, but in some situations you're going to have to use 25 micron, and others. So having the cleanliness from the construction perspective, doing offsite sustainability. You want to talk, Lenny, about how does this approach affect sustainability in terms of doing modules? Is it any thoughts on that? Some? Okay, I'll take it here. We looked at a couple aspects here. Number one, the job site construction versus a, say, fabrication site. The ability to come up with processes to more sustainably manufacture, to capture your waste, to minimize your waste, and then to the concept of circularity. Circularity was a new concept here, and circularity in pipe sounds kind of strange. The concept of what he just talked about, where you started with one pipe solution, you may either add some or you may take away some pipe sections. Seems like a lot of work, but the zero carbon pipe, the second time you use pipe, it's zero carbon. So if you're looking for a CEO passion point, telling you, the CEO that you actually did something with no carbon in your construction really lights people, and that's where sustainability ties in. Supply chain.
I will take this one.
Thank you.
Yeah. And again, whether it was sustainability, supply chain, you want to be able to use the same commissioning in your supply chain as you do in the field. You don't want to have to finish the data center 3 months in advance and then, with the water pipe in and bring something in. The more that the plumbing can be in a modular fashion, the more it can be tested up front, the more players can play. You don't, not being left with, a supply chain constraint because somebody picked a connector style that only worked one way. And so again, it allows someone, if they want to make a special connector, and maybe it goes back to sustainability, is what we do today, from a pitch, we want to reuse the pipe, but at the same time, what if racks go from a 600 millimeter pitch today to a 900 millimeter pitch, to a 1200 millimeter pitch? Do I change the pipe out? Can I have a story that is, that again, from a sustainability and supply chain, can I have that flexibility that as the IT kit evolves over time, I'm not ripping and repeating and having another 3-month commissioning process? Exactly.
So what he just applied to is you change the pitch. Guess what? We're going to need another set of Legos, okay? The first set of Legos we're coming out of is a 24-inch pitch on your IT rack. You go with something bigger, you come up with a different Lego. And you still will find plenty of 24-inch IT racks that will want to use your Legos that you already have. So the concept of reusing components, and not just ripping out and throwing it and trying to recycle, is a huge aspect. The final discussion is really this reduced risk is a key aspect. We're looking at a lot of assemblies, and each one of these assemblies has a potential of leak. They have a potential of contamination. They have potential of all kinds of issues. If you do the same thing over and over and over again, you can drive out defects. You can make a better design. And once you get the perfect Lego, then you replicate that, and it doesn't have to be a copyrighted Lego. Everyone can make the same Lego, and you just come up with a standard. Any comments on that, or does it make sense to you there, Wade?
We need, because it's growing and it's everywhere. It's not just a $3 billion budget from the Department of Energy. It's going everywhere. We need everyone to play. And I mean, we can't just be one source of it. And so, please, participate, and again, even if you just happen to represent a pipe company, we still want you to play. Yeah. Everybody has got a place to play here.
Okay. So speaking of,
can I just,
go ahead.
I just want to touch on the delta T kW per rack. I want to echo what Wade was saying. It looks trivial, but it's not that trivial. Like designing for delta T from CDU perspective, like as Wade was mentioning, like temperature, it will tell you what kind of CDU you are going to use. You are going to tell you what kind of pressure drop you have in your piping system. It's going to tell you, like, if you have 50 kW rack, how many connections you need versus 100 kW versus, let's say, 5 megawatts rack. So all of those, when we are doing the design or we are doing the modular design, it's something that we have to keep in our radars. We are not designing for what we have right now. We have to think futuristic.
Let me, I just show of hands, how many people in this room are involved with the design, fabrication, commissioning, or operations of plumbing systems in data centers? Not enough is what I'm seeing. That's number one. And again, here's the cool call to action. You know, my job is to show how cool this is that in the scheme of things, if you tried to go get your boss at a data center company, even if you got a great boss like Phil over there, I want to go do modular plumbing, they're going to say, well, give me the TCO. Remember how valuable this kit is. You know, it's 98, it's 300 times better, you know, every generation. And so at the end of the day, you should have freedom to go to your boss and say, hey, I need to make 17 different plumbing kits, you know, because the IT kit is what matters. So anybody involved in plumbing should be really excited and say, I heard the NVIDIA guy say, we need lots of different plumbing choices because the IT is what matters.
Right. So one of the things I'm going to move forward here, one of the key topics we had was constructability, and we had previous white papers at OCP that dealt with connection methodologies. Fundamentally, when you're putting together pipe of this nature, you're going to either use flanges or you're going to use what we call mission-critical couplings. So we actually did some evaluation on how those compare. What you're seeing here are two examples of liquid to the rack that were done with one with flanges on the left and one with couplings on the right. We looked at alignment and movement. The fundamental reason that's kept pipes from becoming Legos is the ability of them, once you heat up a pipe, how do the bolt holes line back up again? Couplings have a little bit of ability to adapt both alignment-wise and movement-wise and mitigate that. Risk and reliability. As I mentioned, we actually started doing reliability studies where we actually looked at 18 data centers over a 13-year period with over 150,000 couplings. And we found that when you use mission-critical couplings with a proper inspection method, there were no records of failure. That's like 7 billion hours MTV with no F. The problem with flanges is there is no way to know when you've properly installed a flange. You can't look at a flange, you can't inspect it and know that it's not ever going to leak. So MTBF can't be used for that application. The other thing we looked at was weight in terms of the structural aspect here. And just the very aspect of the coupling there made it a little bit lighter. We didn't come up with any dictation. You can still build with flanges. You can still build with couplings. But what we do is kind of put the information out. People can make their own choices. Moving on here, a more lengthy discussion. Valve train control, this is kind of your passion area, isn't it?
Yeah, it is. That makes me happy, not sad or crying. So it's the connection, this connection between the piping system, supply return, and the racks. Again, it's the valve train, like people call it valve train, people call it branch line. It's basically interesting subject because it not only connection, as I told you earlier, it's not only a connection. It is composed of a connection like a hose or a pipe and multiple valves that's going to do multiple operations. Like, for example, you need an isolation valve. This isolation valve is going to shut the flow from the rack if there is leakage. There is a flow control valve if you want to control the flow to the rack. Problem is, as we were talking about earlier, is this branch line should maintain a certain pressure drop, and each component should have a gauge pressure that should not exceed, right? So when you're cooling high power racks, one is not good enough. Or let's say if you are using 1 inch of this branch line, it's not good enough to cool something like 100 kW. So you need to design multiple of those, or you need to increase the sizes. One of the problems in the sizes, like, you don't have valve sizes that we need in the industry yet. So this is something that we need to work on collectively to see where we are going. I know Don is passionate about that.
Well, I'm very passionate. The only other thing I'm also passionate about is keeping on time. And this is a discussion here that we literally could spend hours on. And actually, we'll be not only spending hours, we'll be diving into this more and more. The Rev 2 of the white paper is coming out next Global Summit. And between now and then, we'll be expanding a whole lot more. And you will see a an evolution of valve train assemblies probably in the next 6 months. I think there's a general agreement. Nobody has the perfect assembly just yet. This is kind of where we're at right now. We are building the plane as we fly it, and we're trying to build it out of Legos, okay? Does that sound about right there, Wade?
You know, I'm more of I'm old school Lincoln Logs or erector set, you know, that I can tighten down with a bolt. But yeah, we need the building blocks to go build it because it's the scalability.
Okay. I'm going to kind of wrap this up. This whole concept, this again is not a presentation of content. It's more of a presentation of a book club review. You may want to go buy this book, and it's free, by the way, so the price is just right. And you may want to take a look at some of these things. Our call to action on this, the white paper, the work stream is going to continue. Updates that we're going to come up with is balancing and flow control best practices. We're going to look for more open methods and procedures for rack connection. Right now, we are kind of constrained on how you physically connect the IT rack to the valve train. And that needs to open up a lot more. And then there's this concept of thermal ride-through. Thermal ride-through means what happens when you have some sort of an issue. And let me kind of put one context and this analogy I love to share. He's talking 130, 140 kW in a rack or something like that. 10 kW is the equivalent of one Weber 3-burner barbecue. It's 34,000 BTUs per hour. So he's put in 13 Weber 3-burner barbecues into an IT rack. What happens when your flow doesn't go very well to that IT rack? Any comment on that, Wade? What happens when you lose a little flow on one of your IT racks?
Well, you design it so it doesn't lose flow.
Exactly.
That is the one and only rule that matters. If you lose flow, then you lose power. You know, if a watt is a watt. Whether volt amp in is a M.CP delta T leaving the rack. It doesn't work with either one of them.
There we go.
Without either one of them.
So along these lines, this here is a link for people that want to join the workstream. This will allow you to enroll in the workstream. There's another workstream that's very similar to this we're contributing to, which is OCP Open Systems for AI, which Madhu is leading. And that if you want to participate in that, that's a QR code that takes you to that workstream as well. So at this point, we got a full 3 minutes for question and answer. Are there any questions, comments, or answers? Hopefully we got the answers.
Don't be shy.
Maybe I can ice break. Hussam, like you spoke about the delta T's on the technical water loop. So this is basically, I think so, for the panel, right? Two things. When we talk about higher delta T, like higher supply temperature and using it from sustainability, how do you see we can capture the heat with CDU in between from the technical water loop for any sustainability project or heat reuse project? And if CDU is there, does the delta T in the technical water loop matter? Like if we are going to see at the chiller side, that's where we gain more efficiency. Could you put your thoughts?
That's a great question. So 2 parts. I really like your question. It's really great. So 2 parts. From the chiller perspective, 100% you're right. Like if your supply temperature is higher, your chiller doesn't need to work much. So you are saving on electric energy for the chiller. On the waste energy, I want to be super honest with you. Didn't think much about it. But since you asked the question, yes, I would say if we have something like to take the heat on the facility water side, right? And we can use it like as a waste energy.
I mean, I think, but I mean, that's the CDU work stream. If there is a CDU work stream. I mean,
and actually, great shout
out.
out.
Plumbing, modularity, the CDUs, the rear door heat exchanger, there's lots of different work streams. Yeah. But I think that the CDUs got to get the approach temperature. They got to understand the delta T, because again, if we don't capture that waste heat, we're making a mistake as citizens.
But Saket, thank you. It's a great question. That shows how everything is connected. Like how whatever decision you are making in this loop is going to impact different things. So it's
another
like
question.
It is. It is a circular design, right? Like,
Yeah.
Well, and we deliberately left CDU out of this because that's its own, like I said, its own work stream. It's got complexities, but it is a work stream, and ACF is pursuing that as also as ASHRAE. ASHRAE TC 9.9, SPC 127 is looking at trying to come up with standards for CDUs.
Thank you, Saket.
I will ask a weighted question. So we know the rack power is growing. For the modular TCS solutions, the workstream is developing, how long do you foresee it can last? How many generations or years can still be applicable?
So at Computex, Jensen Wong, our CEO, said, "Hey, he showed everybody, we're gonna have a new product every year for the next 6 years." But as a data center, you know, one of the things I've said is, and I don't remember who I give credit to, but there's no such thing as a greenfield. I mean, there's always constraint somewhere. So as an industry, we look at, you know, let's say whether it's chillerless, whatever the water temperature is, call it a 3 megawatt cooling block or whatever. The goal is, as an industry, we need to design the shim in between the IT kit and the facility so that we don't stifle innovation in the IT kit. So my answer is, every data center, even a 5-year-old, 10-year-old colo, I look at that and say, I know how I can put 2030, the year 2030, I know how I can put kit in there. It's up to this team to make sure that the shim between the facility power, the facility water, the nuclear generator, you know, whatever the technology is, we can't stifle innovation in the IT.
Thank you. Representing the user side, just want to follow up. Will you give the industry a heads up?
What's that?
Will Nvidia give the industry a heads up on the trend, on the need?
Well, we're here, aren't we? So, you know, that's why I'm on that. That's why we contribute. We do the designs in the MGX rack that we donated to OCP. We're involved in EEHPC work group. We're involved in ASHRAE. So we're, you know, if you think we're not giving it a heads up, maybe you're not in the right meetings, because we're certainly trying to give everybody a heads up.
The challenge is our world is changing so fast. This AI concept is not new, but the generative AI and the benefits of using these higher density processing units is driving literally the tsunami. That's my other presentation, is the tsunami's hitting us. We saw it coming, and now we're just trying to figure out how big it's going to be, but it's not stopping.
You know, I got a better way to answer this. Think about the hyperscalers. You know, I see my friend Kelly Smith back there and other folks in hyperscalers. The world changed from pizza boxes to racks. You know, and if someone said, show me where the pizza box is going to go, show me where the 1 year, 2 year, but now people say, well, where's the rack going to go? You know, if you were sleeping, you missed it. About a year ago, it went from a rack to a pod, to a modular data center. And so whether that building block is 500 kilowatts or 2 megawatts, the data center doesn't care whether it takes me 30 racks to do that or 1 rack to do that. You know, the scale is now the module.
Thank you, Wade, for explanation.
Okay, well, I think we're done on our time, and I know you guys are probably hungry right now. Thank you so much.